Hello everyone, very good evening one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep. And warm welcome to the GATE AIMER'S 2023 series. Join the session quickly and mark your presence everyone. I am Satya, waiting for you all to join the session. Today's topic is recursion. Before I start, let me introduce myself quickly. I am Satya, research scholar with 15 plus years of teaching experience, mentored more than 35,000 students all over India. I am qualified in GATE, UGC NET, SET, and also certified by Cisco. This is quick brief about me. Those who have joined the session, please let me know your presence. Mark your presence, guys, in the chat box. Okay. So guys, now you can get up to 90% scholarship on all our preparation programs. How? You need to take the scholarship test. When? On 10th December, 8 p.m. you will have a scholarship test which is similar to GATE exam. Based on your score, your scholarship would be decided. So, why late? Download our BEP app or website, register from there. Okay. So guys, without any delay, I would like to start the session. When we talk about recursion, the name itself says, so multiple times it happens, right? What this is related to function. What is function? A single statement or group of statements that performs specific task or subtask is called function. Why we require function in the programming? For two reasons majorly: modularity and reusability. Modularity means a big task we are dividing into subtasks. For every subtask you are writing the code individually, independent code. So that independent code, what you can call as module, so that the readability of the code will be increasing. And reusability, we define function once and you can call it to use it any number of times. So reusability, these two are the advantages of functions. And these functions are generally two types: system defined and user defined. The other name for system defined, you can say predefined or library functions. Best examples we can take printf, scanf, getch, getchar, putch, putchar, all the functions that are defined in header files of C library. And best example for user defined, you can say main. Dear friends, main is user defined because the body of the function we define, right? Inside the main code we write, that change from program to program. That's why main is user defined function. Please remember. And a function can be either caller function or callee. Means a function which call another function. Who makes the call? That is caller. Who receives the call? A function which is called by another. That is callee. What are the other names? Caller can also be called as calling function. Callee can also be said as called function. Okay. Now, when this caller callee, whenever they are passing the control between each other, in 4 different ways, these can pass the data among them. That is function prototypes. From caller to callee, the data that flow is called arguments or parameters. And the data that flow from callee to caller, such data is termed as return values. Return values. So, between caller and callee, these arguments return values are not mandatory to flow. That's how we got these 4 prototypes. Functions with arguments with return value, with argument without return value, without argument with return value, without argument without return value. So in 4 ways we can use these functions. Okay. Now recursion. What is recursion? The process of calling itself. A function that calls itself is said to be recursive function. That means caller and callee, when they are same, then you can say such function is recursive function. How long that recursive calling takes place? It should not be infinite, no? So to avoid this infinite calling, what is required to write in the recursive code, guys? Base case. What is base case? It is the condition or state where, when this recursive calling gets stopped. That is what we call as base case or base condition. So whenever we are implementing the program using recursive code, we have to make sure that there is base case. Means after certain recursive calls, that recursive calling should terminate, should stop. Otherwise it would be infinite calling. Memory overflow occurs, segmentation fault occurs, right? To avoid all this, base case is mandatory. Okay. And this recursion broadly you can divide as 2 types: direct, indirect. Direct recursion is again subclassified into 4 types. Head recursion. Head recursion means in the recursive code, in the beginning or in the early lines, we have recursive call. Or else you can say after recursive call, if you have some more code to execute, then you can say it as head recursion. And what is a tail recursion? The recursive call is the last step of the recursive function. Means after calling the function recursively, there is nothing to execute. So that is the last statement in the function. Then you call it as tail recursion. And nested recursion. Nested recursion means what? In one recursive call, another recursive call, something like this: a of n minus 1. In one recursive call, another recursive call. This is what we call as, we say as nested recursion. And then tree recursion. What is this tree recursion? More than one recursive term is there. Something like Fibonacci series, you take a of n minus 1 plus a of n minus 2, we say. Need not to be 1, 2. If more than one recursive call is there with different arguments, we can say it as tree recursion. Hi Aarti, good evening. I am good. How are you people doing? Okay, these are different types of recursion. Guys, for 2023 students, to improve your rank, our BYJU'S Exam Prep has started Rank Booster series on every Tuesday and Wednesday. So, without fail, do attend. This is exclusively for our app users, dear friends. And for 2024 aspirants, we have launched fundamental series where solid concept framework you can build on every Thursday and Friday, and try to circulate this, try to share this information that our BYJU'S Exam Prep is conducting these courses so that many students can benefit, because these are free courses. You could know some students who are unable to afford the paid courses. For them, at least it would be useful, right? So guys, let many students benefit out of these free courses. You only can do this by sharing. Okay, do share without fail, guys. So enjoy our new series on our app. This is exclusively for app users, guys. Fine. Now let us start our practice. Here is the first question. Consider the following function written in the C programming language. The output of the above function or below function, whatever, on input A, B, C, D space E, F, G, H is. Tell me, guys. What would be your answer? Satya, Aarti, everyone. We have a string A, B, C, D, E, F, G, H. There is a space. And we know every string ends with null character. The function name is foo. Function name is foo. The string name is A. We are passing this as argument, so A is the string name, small a. Now, if not star A means the value at where this is pointing to. So A is pointing to this. Character pointer can be a string, right? So A is pointing to base address first. Not star A means if it is not null character, then what you have to do? Foo of A plus 1. That means call the same function by passing B onwards. It is not null, so foo of A plus 1. It is not null, foo of A plus 1. It is not null, space is not null, so foo of A plus 1, and so on. Where it ends the recursive calling? Here. Whenever the pointer points to null, if condition is false, there it ends. And this is head recursion, because after recursive calling, while written, we have certain statement to execute. So while written, what it says? put care of star A, print character at that index, that address. So H. Return put care G. Return put care F, and so on, so on. So what gets printed? HGFEDCBA. The string is printed in reverse. Got it? Okay. Next question. Consider the recursive C function that takes two arguments, n, r. The return value of the function foo when it is called as foo of 545, 8. 545, 8. Solve it quickly. So the first argument is 545, second argument is 8. That means n is 545, r value is 8 initially. Okay. If n greater than 0, 545 greater than 0, return n mod r. 545 modulus r is what? 8. Plus 545 mod 8 is what? Mod will give you remainder. So it goes 8 6 are 48, 8 7 8 8 are 64. The remainder would be 1. Plus recursive calling is there. Foo of n divided by r means quotient. 545 by 8, 68, comma, r is what? 8 again. Okay, Kaustubh says 6. Okay, Kaustubh, let's see. Then foo of 68, 8. 68 is n, 8 is r. It is greater than 0. So what it do? Return n mod r. 68 mod 8. 8 8s are 64. 4 is the remainder. Plus foo of 68 by 8, quotient is 8. Now foo of 8, 8. N is 8, r is 8. N is greater than 0. So return n mod r, 8 mod 8, 0, plus foo of 8 divided by 8, 1, comma 8. So here this is n, this is r. Now 1 is greater than 0 still? Yes. So return 1 mod r, 1 mod 8. 1 mod 8 means what? 1 plus 1 divided by 8, that is 0, comma 8. Now n greater than 0 false. So here it returns 0. So now sum up all. What do you get? 0 plus 1 plus 0 plus 4 plus 1, 6. 6 you get. Yes, Kaustubh. Very good, very good. Next question. Consider the following C functions. int fun1 of int n, static int I is equal to 0, we have certain code, return I. Int fun2 of int n, static int I is equal to 0, again we have certain code. The return value of fun2 of 5 is, it's little lengthy question. First fun2 of 5. So here n is equal to 5. We have I. I is 0. N is equal to 5. I is equal to I plus fun1 of, I am simply writing it as F1, please understand, fun1 of n, that is 5. So what is fun1? Fun1 of 5, here again n is equal to 5, here we have certain value I, it is again 0. If n greater than 0, 5 greater than 0, of course yes, plus I. So 0 becomes 1. Then it recursively call itself fun1 of 4. 4 greater than 0 plus I. It recursively call itself fun1 of 3. So it becomes 3. Fun1 of 2. It becomes 2. Sorry, not 2, 4. Fun1 of 1. It becomes 5. Then fun1 of 0. There it ends. That means if you understand, as n value is 5, I have incremented I by 5 times. Right? So that is the little observation we can make here. Okay? And return I. So finally this 5 gets returned. So here I will be 0 plus 5, 5. This I is different, that I is different. Okay? Then fun2 of n minus 1. Fun2 of 4. What this will do? This again add this I with fun1 of 4. What fun1 of 4 do? Increment I by 4 times. So it is a static. So old values are preserved. So it becomes 9. 9. So I value becomes 5 plus 9, 14. Okay. Now fun2 of 3. I will be that 14 plus fun1 of 3. Fun1 of 3 increments 9 by 3 times. So I becomes 12 there. So that is returned 14 plus 12, 26. Then fun2 of 2. So it add this value to fun1 of 2. What fun1 of 2 do? It do 2 increments on the I value. So that would be 14. So this is 26 plus 14, 4040. And finally fun2 of 1. I value will be 4040 plus fun1 of 1. It increments I value by 1 time. So this would be 40 plus 15, 55. So the final I value in fun2 is 55, return I. So what is returned? 55. Got it? Okay. Next question. Consider the following C function. Int fun of int n, int x is equal to 1, k, if n equal to 1, return x. For k 1 to n, x equal to x plus fun of k into fun of n minus k. These are called tree recursions. Return x. So the return value of fun of 5 is it is again lengthy question. Let's do it. Let us do it. So first, fun of 5. N is equal to 5. And every time recursively call this function, x is created, k is created, because they are local variables, not static. So every time they gets created. That is one observation we can make here. And when n is equal to 1, then x value is returned. Whatever the x value we have at that time. Okay. Now, whenever you call this function, every time this loop run for n times. So when fun is equal to fun of 5, it run for k equal to 1, k equal to 2, k equal to 3, k equal to 4. 4 times it runs. X is equal to x plus, by that time x is what? 1. So 1 plus fun of k, fun of 1 multiplied by fun of n minus k, fun of 4. Until you get this value, you can't go with the next loop. So let us calculate fun of 1 first. Here n is equal to 1. When n is equal to 1, return x. What is x? 1. So fun of 1, return 1. Return 1. Now fun of 2 I want. Why, sir? We want fun of 4, no? See, here when I do x is equal to that previous x plus fun of 2 I want, fun of 3. Here x is equal to x plus fun of k, k is 3, fun of n minus k, 5 minus 3, 2. Here x is equal to that x plus fun of 2 into fun of 4 into fun of 1. These are what the recursive terms we get. So fun of 2 is needed, fun of 3 is needed. So let us calculate in that sequence so that it would be easy for us. Here n is equal to 2, x starts with 1 again. Now k is equal to 1. So x is equal to x plus fun of k into fun of n minus k. 2 minus 1 is again 1. So this is 1 plus 1 into 1, because fun of 1 returns 1. So this is 1 plus 1, 2. So fun of 2 do what? Returns 2. Now fun of 3. N is equal to 3. X again starts with 1. k starts with 1 and 2. So when k is 1, because it's a loop, right, every time. When k is 1, x is equal to x plus fun of 1, yeah, fun of k into fun of n minus k. Here n is 3. 3 minus 1, 2. We got f of 1, f of 2, that is 1 plus 1 into 2, that is 1 plus 2, 3. X is equal to that 3 plus fun of 2 into fun of 3 minus 2, 1. So this would be 3 plus 2 into 1, that is 5. So finally x value becomes 5. So fun of 3 returns 5. Now fun of 4. N is equal to 4. X is starting with 1 again. Now k run for 1, 2, 3 times. So x is equal to x plus fun of k into fun of n minus k. So that is 1 plus fun of 1 is 1, fun of 3 is 5. So 1 plus 5, 6. Now 6 plus fun of 2 into fun of 2. This is 6 plus 2 into 2, 6 plus 4, 10. And when k is 3, 10 plus fun of 3 into fun of n minus k. N is 4, 4 minus 3, 1. So this is the 10 plus 5 into 1, 15. So finally fun of 4 returns 15. So we got all the written values for fun of 1, 1, fun of 2, 2, fun of 3, 5, fun of 4, 15. Now we can substitute them here. So this is 1 plus 1 into 15, that is 16. That 16 plus 2 into 5, 26. That 26 plus 5 into 2, 36. That 36 plus 15 into 1, 51. So finally, what is the return value we got? 51. Yes, Kaustubh. Yes. Very good. Very good. Understood, everyone? It's a very good question, though it's a lengthy question. If we can do this question, definitely we'll gain the confidence on recursion. Okay? Next question. What will be the output printed? Void fun of int x. If x greater than 0, fun of minus minus x. Print x, fun of x minus minus. Int main, int a equal to 3, fun of a. Fun of a. Fun of a is what? 3. So x is equal to 3. 3 greater than 0, yes. So it is tree recursion. Fun of minus minus x, it's a pre-decrement. So x gets decremented, then called, means then passed as argument. Print x, x is 2. Then again recursive call, now post decrement, means first passed the argument, after that decrement. Now fun of 2, x is equal to 2, greater than 0, yes. So fun of minus minus x, print x, fun of x minus minus. The other side also same, fun of 1 print 1, fun of 1. Now what is fun of 1? X is 1, x is equal to 1. Pre-decrement fun of 0, print 0, again fun of 0. So every fun of 1 will be that only, fun of 0, print 0, fun of 0, 0, print 0, fun of 0. Right? When x is 0, recursive call won't take place. So fun of 0 will not do anything. Now you keep printing. You keep printing. So 0, then 1, then 0, then 2, then 0, 1, 0. Means in the in-order traversal way. So we got 0, 1, 0, 2, 0, 1, 0. A palindrome, of course. Got it? All right. Now I am giving this question for your homework. Practice this question, everybody. It is again, in fact, a very good question. And the answer for this question, let me tell you, is option D. Option D is the answer for this question. Okay? Try this. That's all for today, guys. Recursion. This is my Telegram group link. If you have not joined yet, you may join to connect with me, to get all my class details, and also you can discuss with your peer students. So many 1,000+ students are there in the group, so you can discuss with them. The peer group learning can take place. So many doubts gets cleared, and you will get the class PDFs also. Okay? So if you have not joined yet, do join, guys. Thank you so much for attending my session. That's all for today. See you in the next session. Till then, have a great time. Don't forget to like the session, share, and subscribe to our BEP channel. Thank you, guys. Good night, everyone. Take care. Bye-bye.